Firefox. Oh, okay. So this is an example of our data visualization technology. So what we've done is we've developed technology to navigate through databases at very high speeds. And the first area where we've implemented this is in geospatial data visualization. We literally take databases with millions of records. We create geospatial environments that allow people to navigate through them in real time. And let me open, and there are several sites that are open to the public. Census maps. Oh, something finds something. Okay, let's go. So this is an environment of California. And as you see, I can zoom in real time, and the information is supposed to update. What you can see on the, oh, I need to refresh this. I need to reload this, of course. That's the problem. So there we go. So what you see over here is I'm looking at the Census 2010 database, and as I'm zooming in, the numbers on the right are updating in real time. I'm running this in the cloud on servers, I don't really know where, inexpensive servers, and as I'm zooming in, the information is updated instantly. What you see here is the Census 2010 database. I'm coloring it by race. So in this case, the yellow dots are census blocks with majority white population. The blue ones are majority African American, and yellow are majority Asian. What I can do is I can go in and actually create heat maps of that. So what I did just now is I created a heat map of the Bay Area showing percentage of African American population. All of this is done in real time. So I can actually zoom in on individual census blocks, and I can go down to the block level, and then I can pull up information about a specific block. And again, you know, I'm navigating in real time here over the internet, over a Wi-Fi connection, in a database with maybe 10 million records. So what I have on the side, I was looking at the Census 2010 data. What I can do is I can switch to a different data source at any point. So here I'm pulling up the Census 2000 data. And again, I can pull up the information. I'm inside of Google Maps, so I literally, I can have all of the tools available, our solution functions both inside of Google Maps as well as Bing Maps. The other thing I can do is I can export information basically instantly about the records that I'm accessing. So another database, and I'll have to log in for this one. So this is a database with over 100 million records. This is the largest one that we've visualized. It's behind a login, so let me log in. People, please don't look at my password. So there we go. And then I go to the Census 2000 database. There, it was there. And I'm pulling this one up. So we're looking at a database with over 100 million records. It's really interesting, actually. For instance, if you look at this data, this is basically population data for the United States, obviously, for 2000. What you see here, you see patterns emerge that would be harder to see. This is all flat. The cities were created at the intersection of roads and railroads. And if you zoom in, each time I zoom in, the data is recreated. This is not a situation where I have some imagery and all I do is zoom in. So I can open the side panel, and I can look at ethnicity and age over the entire US. So what I'm doing right now is I'm browsing through over 100 million records, and I'm looking at ethnicity. And again, I can go in and say, okay, I want to look at African American population, and it's regenerating that right now, and then I want to see that as a heat map. So I'm looking at African American population in a heat map, and it's generating that in the background. I hope. Or did I lose connection? I probably did. So another example, our technology is currently being used by several states. Pennsylvania is using it in several departments, and so is Oregon. One of the applications that it's used at is redistricting. Oregon House dot Borderline.com. No. Do you remember the URL, Bob? So, okay. So let's switch to a different data set. Logging out. So it can be used for, oh, I know a server I should go to. It's one of those things when you work on the cloud, which is great, you have too many servers before you know it. Borderline.mobile.com. Yeah, So this is an environment that's used for redistricting, and this is actually being used in Oregon right now and in several other states as well as on the local level. What's interesting here, so this is political data. This is information on an address level. So what you see here, if I zoom in, I actually see individual houses. And so this is a database with 2 million records on the house level. What's interesting is I can actually switch at any point and I can say, now I want to look at data on the block level. So I can switch between those. I also have the ability to generate spreadsheets automatically from my environment. So what I can do is I can look at different, in this case, redistricting scenarios. I can edit districts and I can actually go in and regenerate spreadsheets from it and export them at any point in time. All of this is real time. And then, of course, last but not least, what I have is the ability to display boundaries and look at all kind of geometry with boundaries. So we took this one little step further for a customer, and the customer in this case is the Sightline Institute in Seattle. What they wanted us to do, and that's what you're seeing here, is we took 20 years of census data, basically 3 periods. This is the Portland, Oregon area, and what you're seeing is you see population growth taken from the census data from 1990, 2000, and 2010. What they were interested in is to visualize urban sprawl. So for instance, if you look here, up in the left corner, you see it starts out green, and it fills in slowly with population between 1995 and 2000. And you also see, if you look at downtown Portland, that there are certain red dots that are emerging and they're growing. So we're really looking at a time-lapse animation of 20 years of population changes in a major metro area. So, okay, that's it. I'm too early.
Questions? Yes, we have a gentleman in the back.
You mentioned that the technology was allowed a speed up of accessing data 100-fold. Could you talk a little bit about how that was achieved and what it entailed?
Yeah, so what we did is over the last 3-4 years, we looked really closely at basically how processors work and how you can structure data. So obviously we're running everything from RAM. There's no other way to do that. But also how you structure the data so that every reload from RAM into processor cache grabs as much relevant information what you will need on the next search. So we really optimized the technology. One thing I didn't mention is, of course, this is completely data agnostic. It doesn't matter what type of data we visualize. So, you know, we've been working with data about epidemics. We've been working with data about people, census data, you know, anything. So.
It's always geographically related?
No. We have a text search that we're working on the same technology, and we think that we'll also be able to dramatically speed up data retrieval for text-based databases.
Other questions?
Okay. Thank you very much. Yeah, thank you. Oh, you want your toys back, huh?